The next topic we're going to look at is inscribed angles. So ordinarily, we're used to seeing an angle that starts at a point on a circle, going to the center, and then going to another point on the circle. Central angles. An inscribed angle is an angle that has a vertex on the side of the circle and contains a chord. So an intercepted arc has endpoints on the side of an inscribed angle and lies on the interior of the inscribed angle. So what does this look like? So we have three different cases. We have case one, where the diameter and a segment run off to the side. So the inscribed angle here is going to be that. Case two, point P is contained within the inscribed angle. And then in case number three, we have the center P on the outside of the inscribed angle. So these are the three scenarios we could possibly end up with in terms of where we have an inscribed angle in relation to the point of the center. So the inscribed angle theorem says if an angle is inscribed in the circle, then the measure of the angle is 1/2 of its intercepted arc. So, unlike the previous lesson where we had a central angle, meaning the center was where our angle was located, the arc ended up being the same measure. An inscribed angle says the angle itself is half of the arc. So this would mean angle 1, so if I take a look at the circle, angle 1 is equal to half of arc AB. So that is how we're going to figure out measures of arcs and angles. So here we need to figure out the measure of angle P and arc PO. So we're going to use this theorem to figure out our angle measures. So angle P is this guy right here. So the theorem states the angle itself is half of the arc. So here the intercepted arc is MN. So this would mean angle P is half of arc MN. Well, according to our diagram, it says MN is 70 degrees. So I cut it in half, and angle P is going to be 35 degrees. So arc PO is what we have to find out next. So PO is that. So what this means, again, we're told angle N here is 56 degrees, and now we have to figure out the arc PO measure. So the theorem states, in our case, the theory states angle N is equal to 1/2 of arc PO. Well, angle N, in our case, is 56 degrees. And that's half of arc PO. Well, we have to get rid of that fraction half, and we do that by multiplying by what's in the denominator of a fraction. So if we're dividing PO by 2, that means we have to multiply both sides by 2. So what that does is it'll cancel out the 1/2 and the 2. And when I double 56, I get 112 degrees for arc PO. So if I am going from an arc to an angle, I cut the arc in half. If I have an angle and need to find the arc, I will double the angle measurement. So we can use that in our next example to figure out, in our case, arc CF and angle C. So what we have to do here is we have to take a look at the circle. We need to locate the pieces we need, and we need to figure things out. So here we have this circle. It doesn't give us a center. We have arc DE being 90 degrees. We have angle D being 40. So CF. So arc CF is right there. I take a look at the intercepted angle, which is angle D, so the inscribed angle is D. If I have the angle measurement to find the arc, I double it. So arc CF is double 40, so that's going to be 80 degrees. Angle C is going to be this guy right there. So if I take a look at the intercepted arc, so here is C, there's angle C. The intercepted arc is DE, it's 98 degrees. So again, arc to angle, we divide by 2. So in this case, it's going to be 98 divided by 2, which is going to be 49 degrees. Gives me angle C. So again, if I go from an angle to, if I have an inscribed angle, meaning the angle is on the side of the circle, it's not in the center. In order to figure out the arc, I will double the angle measurement. If I have the arc measurement and I need to find the inscribed angle measurement, I will divide the arc measurement by 2. Now the next definition we have says if we have two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So here we have circle with two inscribed angles at angle C and angle B. They're blue and red in our case. Notice both have arc DA as the intercepted arc. Because they have the same arc as the intercepted arc, then the angles are going to be the same. So that would mean, in our case, angle C is going to be congruent to angle B. And we still follow the same rules that apply if we're given angle measurements and we need to cut in half or multiply by 2, depending on the situation. So, for example, we have these two inscribed angles, angle T and angle U. They both intercept the same arc of SV. We need to figure out angle T. So here we have SV, and we have the two intercepted angles. So we have angle SUV, and we have angle STV. So again, they both share the same arc, so that means our angles are going to be the same. So if angles are the same, I can always set them equal to each other. So 3x minus 5 equals 2x plus 15. What I want to do first is I need to solve for x. So what I will do here is I will subtract 2x from both sides. So we get x minus 5 gives me 15. And then I'll add 5. So we get x equals 20. So if x equals 20, that means I can input it into what angle t is to figure out what the angle measurement is. So angle t is 3x minus 5. X is 20. So 3 times 20 minus 5. 3 times 20 gives me 60. Subtract 5. And I get 55 degrees equals angle t. So therefore, once again, angles that share the same arc, or rather inscribed angles that share the same arc, will have the same measure. So that's why I was able to set them equal to each other. Solve for x, input it into the expression, and therefore I can find angle t. Now B says if angle S is 3x and angle V is x plus 16, we need to find the angle of measure S. So what we do now is we have to take a look at what angles we're talking about. So angle S is 3x. So here's angle S. Angle V is x plus 16. We need to find the measure of angle S. So let's first of all see if they share the same arc. So here's the angle made by angle S. So arc TU is the intercepted arc. For V, there's the angle, there's the inscribed angle at V. It also shares the arc TU. So therefore I can say the two angles are the same. So that means I set them equal to each other, solve for x, and then plug it in. So we have 3x equals x plus 16. I'll subtract x. So we get 2x equals 16. Divided by 2. So we have an x value of 8. Now that I know what x is, I can plug it in for angle s. Well, angle s is 3x. So angle s means 3 times 8, which means angle s is 24 degrees. So again, inscribed angles sharing the same arc are going to be congruent. Set them equal to each other, and we can figure out angle measurements, missing pieces of x, and everything that's related to it as well. So the next thing is what's known as Thales theorem. So what it says is an inscribed angle of a triangle intercepts the diameter of a semicircle if and only if the angle is a right angle. So what this means is obviously the angles off the diameter are not going to be right angles. So that would mean angle G being the inscribed angle here has to be a right angle if the angle intercepts the diameter. And we can usually tell it's running through the diameter because they typically label the center with a point and a letter as well. So in this case, they gave a point in the center here, running, and FH runs through it. So we can say that is a diameter. So what this would mean is we have an inscribed angle at G, and it creates a triangle. Therefore, angle G is a right angle. So here we need to find measure of angle F in this given triangle. So again, we have circle J, again, diameter running through it, FH, angle G. So according to Thales theorem, because the inscribed angle creates an arc that is created by the diameter, so again, angle G is the inscribed angle, therefore FH is the arc. So we have an inscribed angle creating a right triangle, and we know that triangles, the angle measurements add up to 180 degrees. So to figure out the measure of angle F, I have to add up all my angles and get it equal to 180 degrees. Or what we can do is we can say our two unknown angles are equal to 90, because 180 minus 90 gives me 90. So first things first, 4x plus 2 plus 9x minus 3 plus 90 gives me 180. Add our like terms, 4x and 9x makes 13x. 2 minus 3 plus 90 gives me plus 89. Gives me 180. I'll subtract 89. So we get 13x gives me 91. I'll just divide by 13. And we get 7. So we know the value of x equals 7, but we were tasked with finding angle F, so I have to apply 7 for x into 4x plus 2. So we know angle F is 4x plus 2, which is really 4 times 7 plus 2. Well, 4 times 7 is 28, and I add 2, which means angle F is 30 degrees. Now let's say angle F is 7x plus 2, and angle H is 17x minus 8. We need to find x. So they change the value of angle F and angle H, and they test us with a different task. So this time we're just finding x. So F, H, and G, again, it's all the same. We have a right triangle. The inscribed angle creates a right triangle due to endpoints running through the semicircle. So we can add these plus the 90 degrees to get 180. So 7x plus 2 plus 17x minus 8 plus 90 gives me 180. So add like terms, 7x and 17x makes 24x. 2 minus 8 plus 90 gives me 84. I'll subtract 84. And we get 24x. Gives me 96. Divide by 24. And I get x equals 4. So that was our task in this one. Find x. We found x. 96 divided by 24 is 4. Therefore, we are done with that one. Now let's say in this figure below, AB is the diameter of a circle of radius 17 miles. If B to C is 30, what is A to C? So, again, inscribed angle running through the diameter, so we can say the angle is 90 degrees. We know B to C is 30. A to B is the diameter, 17. And we need to figure out A to C, that side. So if A to the center is 17, then the center to B being a radius, it's also going to be the same measure. So 17, 17. So we can say the whole way from A to B is going to be 34. So here we can use the Pythagorean theorem. Again, if I have a right triangle, I can use the Pythagorean theorem. If I know 2 out of the 3 sides, I can find the missing third side. Again, Pythagorean theorem, a squared plus b squared is c squared, where I have to square the 2 short sides and add them together, and it's going to be equal to the square of the hypotenuse. So the hypotenuse is always going to be across from the right angle. So if I were to state A, B, and C, C being the hypotenuse across from the right angle, that's going to be 34. And again, A and B doesn't really matter which of the two is our unknown, so A can be our unknown x, B would be 30. So we can plug these numbers into our equation. So we have x squared plus 30 squared gives me 34 squared. So we can't do anything about x squared. 30 squared is going to be 900. And then 34 squared is 1156. So we're going to subtract 900. So we get x squared is 256. I want to take the square root of both sides, because that will cancel out the square root of the square. So we get x equals, and then we'll just take the square root of 256. 16. So AC is 16 miles. Can't forget the notation, unit of measurement. And then in number 3, we have the circle. BC is the diameter, center A. We need to find the measure of DAB, BAE, and angles DAE. So we got a bunch going on here. So we know B to C is diameter, and we need to figure out DAB. So this is the angle that we have to figure out, DA to B. So first things first, we need to find out angle measurements or arc measurements. So we know because that B to C is a diameter, then that means arc BC, well, rather BEC, is going to be 180 degrees. We also know conversely the other way around, BDC is also 180 degrees. Now what we do need to figure out is some pieces that we don't have. So, first things first, we see inscribed angle B. Now the inscribed angle created by it is intercepted by arc CE. So C to B to E. So the angle measurement is 26. So this means I have to double it to figure out arc CE. So arc CE, 26 times 2 is going to be 52 degrees. So the arc CDE being 52 degrees, we also have the central angle of CAE. And again, central angles are the same measure as the arc itself. So that is also 52 degrees. So there's that part as well. So if arc CE is 52, to figure out arc BE, I subtract 52 from 180. So 180 minus 52 means this one is 128 degrees. So arc BE is 128 degrees. And again, we have central angle BAE. So we have the central angle. Again, central angles also have the same unit of measure as the intercepted arc. So central angle A is going to be 128 degrees. So now we're getting someplace. So question becomes, what do I have now that's going to help me out figure out these angle measurements? Well, so far we got this side, and now we need to figure out this part. Well, here we have angle DAE. So angle DAE is going to be a right So with angle DAE being a right angle, we know that this part plus 52 is going to be 90. So what I have to do, 90 minus 52, gives me an angle of 48 degrees. So with this being 48 degrees, and that means D to C is also 48 degrees. And now that we know 3 out of the 4 central angles, we can now find the missing section of the central angles. So again, angles of a circle add up to 180 degrees. So we know our DAB is going to be 360 minus the 48 minus the 52 minus the 128. DAB. So we do the subtraction piece. And we get an angle measurement of 132 degrees. Part B, find angle BAE. We already found it by using what we know. We know diameter created 180 degrees. And using inscribed angle theorem, we found this arc CE to be 52. We subtracted it to get 128 degrees, and the fact that central angles are the same measure as the intercepted arc means that is 128 degrees as well. And we have to figure out arc DAE. Again, we already found out the measure of it as well, being 90 degrees. So again, that was using pieces of what we know, the inscribed angle theorem, central angle theorem, inscribed angles, arcs, and all the different necessary theorems and math, geometric math, to figure out the missing arcs and angles. Now this one, number 4, says rectangle ABCD is inscribed in circle P. Boris says diagonal AC could pass through the center but does not have to pass through the center. Is Boris correct? Explain your answer in words or draw a picture to help explain your theory. So basically what this means is he took a circle. We're going to say this is a circle. And what he did was he put a rectangle inside of it. So basically we have a center P. And what Boris says is if we have rectangle A, B, C, D, that the diagonal from A to C could pass through the center but does not have to pass through the center. Now, depending how big the rectangle is and where you inscribe it, well, it's highly unlikely that it would not pass through the center. So my point is a little off center. So in this case, if we draw a rectangle again is two sides that are congruent, opposite from each other, meaning A to D and B to C have to be the same, and AB and DC have to be the same as well. So points A and D are going to be equidistant as points B and C, meaning if I were to draw a diagonal, then it's going to, the diagonal will indeed pass through the center. The only time it would work is if you drew a rectangle that was not inscribed. So, inscribed means we have angles that are created by the points actually touching the circle. So, if you had a different circle and you just drew a rectangle in there somewhere, I can say that's a rectangle. Obviously, the diagonal will not run through the center. However, if you create a rectangle where the angles are inscribed on the circle themselves, the diagonals will indeed pass through the center. So, number 5, we have to prove that y equals 2x in the diagram. So here we have angle B labeled x and angle DAC labeled y. So the ultimate thing we have to show is that x is, or y is equal to 2x. So first things first, we can say because DAC is a central angle, we can say, so arc, so we can say arc DC equals y. Now B is an inscribed angle, so the intercepted arc for angle B is DC. And what we learned with our theorem states that the arc is double the angle. So we can say that angle DBC is equal to 1/2 arc DC. So arc DBC, the angle measurement is x, is 1/2 arc DC. So to figure out arc DC, we would multiply both sides by 2. So we get 2x equals arc DC. So if I take a look at it, arc DC equals y and 2x equals DC. Because we have the same thing, we can substitute y for DC. So now we can say, or we can substitute 2x in for DC. So we can now say 2x equals y. So again, because we have both y and 2x equal to DC, I can set them equal to each other. Therefore, 2x equals y. Now for these last four, we get to find the measures of the labeled angles. So in our first problem, we have angles y, measures of 28, 74, x, and x. So first things first, we gotta start writing down some stuff. So what do we know? Well, we know that here we have x, y, x, 74, 28. We can use these different theorems in order to figure out these different pieces. So what we can say is BC arc BF, because it has an inscribed angle BCF, we can say BF is 2x. And we can say the same thing for FD, because the inscribed angle here is FCD. Again, inscribed angle, the angle measurement is going to be 2x. Now, fortunately for us, if I take a look over here at angle FDB, we have an inscribed angle of 28, meaning arc FB has to be double 28. So that's going to be 56. So 2x equals 56, which means if I divide by 2, x is going to be 28. So therefore, I have now found the value of x. X equals 28. So we could say that's 28. We could say that's 28. And then we have this nice triangle here, triangle BCD. We know 1, 2, 3 out of the 4 missing pieces. So 28 and 28 makes 56 plus 74 plus my angle measure of y, because it's a triangle, it's going to give me 180 degrees. So if I combine my like terms, 56 and 74 gives me 130, plus y gives me 180. When I subtract 130, I get y is 50 degrees. So using inscribed angle theorem and then the overall measurements of a triangle, I'm able to find x and y. Now for angle B, I have angles of 34 degrees, 14, y. So what I need to do is I need to figure out what exactly is missing here. So how are we going to figure that out? Well, we know due to inscribed angle theorem, CGB is going to be double y. And we know that FG is going to be double 14, so that's going to be 28 degrees. So F to G is 28. And then we have that 34 degrees on the outside. So due to 34 being on the outside, again, we can view it as an inscribed angle, 34 degrees. So double y is equal to, so that's 2y. So the angle measurement, I have to double the angle measurement. So 68. So if I divide by 2, y is going to be 34. Now C, I have angle measurements of x, 112, central angle of BAC, and then I got angle D of 40 degrees, and we need to figure out, obviously, angle X. So, we know using, what we have, so we know this angle is 112, and because this is 112, 180 minus 112 is going to give me a 68-degree measure. So, first things first, angle BDC is 40 degrees. So again, inscribed angle, intercepted arc is double the angle measurement. So this would mean angle BC is 80. So because BC is 80, the central angle created by the intercepted arc is equal to the angle measurement of the arc. So the central angle BAC is 80 degrees. So here we have this triangle where angle measurement of 80, 68, and x is going to give me 180. So 148 plus x gives me 180. And then I subtract 148 and I get x equals 32 degrees. And then letter D, we have angles of x and y that we have to figure out. And we are given a central angle of 120 degrees, and we are told angle AEBA is 24 degrees. So how are we going to figure this out? Well, I'm going to try and use our inscribed angles in order to figure it out. So central angle BAC, so this would mean arc BDC is also 120, which means on the outside, BEC 360 minus 120 is 240 degrees. So far we got the outside angles, and we need to figure out everything else that's going on here. So if this is 120, then that means this is 240. So from here, what we're going to do is we are going to try and figure things out where, let's see, so what we can do is we can extend on out. So if we extend on out, what we can say is we now have this inscribed angle. So this means this portion, so we use ABCD, we'll say this is F. So because angle B is 24, that would mean this arc is 48. And we know with the inscribed angle theorem, because we have the angle measurement D here, the intercepted arc BEC is 240, then that would mean half of 240 gives me y. So y is going to be 120 degrees. now that that is all set, we can now try working on angle X. So angle X is composed of DCE. So what we can do now is we know we have this parallelogram, or could be a parallelogram, but we have a quadrilateral down here, 24, 240. We figured out using just extending the line that we were able to figure out point E at the arc is 48 degrees. And what we can do now is we can essentially do the same thing that we just did with angle Y to figure out what angle X is. So if we know that that's 48, we know that D to E is going to be double X. If we do the same thing where we extend the line off of X, we know arc GE is going to be double X. So using what we learned, if I have two inscribed angles intercepting the same arc, then the angles are going to be the same. So angle B here and angle X will be the same. So angle X is going to be 24 degrees. So that is using inscribed angles and using arc measurements in order to find the four missing pieces. So again, inscribed angles, half of the given arc, central angles are equivalent to the arc measurements, and we can apply that to find missing angles and creating right triangles within the circle.